and welcome. So we were talking about this AST computer as one of my first videos that I did on the YouTube channel, and I spoke very politely and very nicely. But we've moved on since then, and we're now speaking like a docker. This power supply here is from that AST computer, and I just gave it a quick clean on the inside, a quick dusting. But I still got some dust here and there, you know. And the reason why I opened it up was the PC hadn't been turned on since that last video, and actually there's dust over here now. And I decided to turn on the machine just to basically take it out of storage, just to basically give it a run, see what's going on, see how things are getting on it. And I basically turned the machine on and booted up, turned on the BIOS, or BIOS settings. Had basically been forgotten because the battery isn't in the best of shape. So I went into there to the BIOS, and we'll show you that again, don't worry. So I went into the BIOS and we set them all up and got that all going, and set the hard drive up as specified, and got it running. So the machine turned on, it started to boot or whatever. I walked away, I didn't do anything else. But one of the things I did here was I heard a bit of a like a creaking door, like the hard drive needed oiling. Or something needed oiling. It's a sort of that sort of a way. That's a great impression, I know. So it was sort of a creaking sound. I didn't know what it was exactly. I ignored it. I walked off. I'm actually currently scrapping a whole load of Laserdisc drives, and don't worry, folks, they're no use. You have to get rid of this stuff eventually. So there's a few of them that are going there. I had about 20 or 30 of them. So the useless ones have been scrapped. A few more of them to get scrapping, but I was doing that and tidying up on the usual crack, and I walked away, and when I came back the machine wasn't doing anything. The power supply was just hissing. So I said to myself, oh mother of God, the power supply is at the blowing up. And what was interesting about it is that somebody on YouTube actually asked me on my other video, did I have any of these power supplies spare, and I should have one or two of them spare elsewhere, but at the moment I don't have any access to them. So the first thing I did was I put in a standard AT power supply, plugged everything up, turned the power supply on, and this is a standard AT power supply, don't get me wrong, it's just not a standard size, okay? So I plugged in that AT power supply, everything was running fine. And if I say everything was running fine, I just basically plugged in the motherboard connector, sorry. So everything was running fine. I then decided to plug in the two floppy drives and the hard drive, and lo and behold, I'm standing here and going, what's that smell? Oh God, something's burning, you know. I thought to myself, maybe I'm about to blow another power supply. It's fairly tough, these power supplies. This particular one is actually fairly tough. I've had a few of these where they've been wired backwards and all sorts of stuff, and these power supplies have survived. They're pretty good, and they tend not to want to obliterate your 386, or 486, depending on which model you have. But I still wasn't too sure what the story was. So first thing that came to my mind was dodgy hard drive. So took out the hard drive, powered the machine up, and yep, it started to boot up. The problem now is that my 40 megabyte hard drive is dead and buried, so I had to upgrade it to a 1 gigabyte hard drive. Yep, 1 gigabyte hard drive. So we'll have a look at that. We'll see what we've done there. And the reason why I took this apart was just to basically have a look inside, see if anything had bust. And everything looked okay. Cap wise, it looked like anything was busting it. And the two big fellas down here seem to be okay as well. So it seems to be okay. It looks visually alright. There's no leaking or bulging or crapping out. So that's always good. So and there's the bridge rectifier there, look. My thumb is this, the fella here. So everything looks okay, everything looked fine, and nothing in there apart from a bit of dust. So I swept the dust off it just now, but I booted up with the 1 gig hard drive and everything seems to be working fine. So now we're going to get on with the next bit of the video. We're going to basically go again and have a look and re-explore. Okay, this is like a blast from the past, made in Ireland. So this is made in Ireland, so of course it's the best network card you can get because it's made in Ireland. Manufactured in Éire, I should say, Éire. Gumaleshke, apologies. So, manufactured in Ireland is the Etherlink 3. What's great about this is it has your options for everything: thicknet, tinnet, and Ethernet. ThinNet, AOI, Ethernet. we use today. This one here is quite handy too if you want to link up a few machines on the cheap with a coaxial cable and have the correct terminating heads. Basically, you daisy chain them together with terminators and all the rest of it. I'm not even going to go down that route. I do know how to do it. I have done it in the past. I remember one customer was looking for a cheap network and this was readily available, this type of cabling, and they said no, we have an existing network. And I tried to explain to them that this is the way forward, this is the way things are going to go in the future, and they insisted that this was the way to do things. Problems happened. I can't discuss them, but needless to say, getting money out of them was quite difficult, and they blamed me for their bad network. I said, this is the problem, because if one PC isn't working on the network, the whole network goes down. Whereas with this system, it doesn't matter if 10 of the machines are broken and one's still working, you're still on the internet. And have a guess what? We still use this today. So, this connection here is great to have on it. It's a 16-bit ISA card, as you can see. So we know it's 16-bit because we have the dual connectors. This is the 8-bit. And then this is the additional piece that gives it the 16-bit bus. This is 16 lanes of information being able to transfer around the machine. Okay? Nothing on the back of the card of any great consequence. This chip here is missing. Will be on most network cards, but basically it's used to allow you to boot from the network directly by using a chip that's here. The other way to do it is to have a computer with no hard drive in it. And this isn't a disk, but I'm just going to give you an example. You then basically have a boot floppy disk of some description, which will then boot the machine into an operating system like Novell NetWare, and it will then ask the network card to communicate with the network server, and then the machine then runs as a dumb terminal. So what that means is that all your files, you can still save to A drive or B drive floppy type disk, but it means that all the stuff that is actually saved, the hard saves, are done on an external server. It also means that machines with just a network card like this 386 here that I'm going to show you, and they don't have an existing hard drive, because hard drives were expensive or non-existent, but generally they were expensive. It allowed you to back up the files to a central location, number one. Number two, it meant you only needed one main hard drive in a server, or preferably two, one for the main usage and one for the backup. And it also meant then that your machine didn't have to have the information saved on it. You could just do your simple, backup and go on a floppy disk. Okay, so now we're going to go ahead and have a look at the 386 machine yet again. So, okay, so what we have here is we have a proprietary card from the great people at AST Research. So this is the 386 CPU board. So we basically have our chips on the board. And I'm going to go through what each one of them is within reason. So we have our clock oscillator here, our crystal. I'm going to turn it around so it makes things a little bit easier to actually see. This is a proprietary slot from AST, and this is an 8-bit slot here. So remember I was talking about 8-bit and 16-bit, you see? So this is an 8-bit slot. So this is basically just allowing probably power or communication to the board. Let's see, it's pretty good trace where they're going, come here. Probably not, I think it's double-sided board. It would be quite difficult to figure out where they're going. Yeah, it's going to a little capacitor here, look, one of them. But yeah, so basically most of the information is going down through this proprietary slot at the end here, and this slot at the end is a 32-bit, because this is known as the AST Qubit 32 BIOS system. So the Qubit 32 was a machine from a line of machines from AST that allowed 32-bit genuine access with the 386 CPU and the motherboard. So in theory, if you run 32-bit software, you should get a higher speed. But ironically, most 32-bit software is, have a guess what? Built for Windows 95. And this machine doesn't really like running Windows 95. One of the reasons being is that the memory is only 4 megabytes, 1, 2, 3, 4. So the minimum requirement realistically for Windows 95 is 8 megabytes. It will run on 4 megabytes, but by God is it slow. One of the things I did do with this 386 back in the day is, it actually wasn't this one, this is a 25 megahertz machine. And the one I used was 16 megahertz with no maths coprocessor. But I digress. So I actually upgraded this to maths coprocessor recently enough, just before the last video in that sense recently. It only had the 386 chip, so I put the maths coprocessor into it just to give it a little bit more speed. It'll give it speed in some applications, not all applications, but it does help. So basically this is for the WearTech type maths coprocessor, just in case you're wondering. I haven't got one so I can't show you, but you either choose the Intel version or you choose the WearTech version. Okay. This socket here is also pin compatible with the Cyrix range of CPUs. I am nearly sure I tried on the other board to put the Cyrix chip into it and I had some problems. Now, one of the things you can also do on this board, which in the case of the AST should in theory make a big difference, is you can get an upgrade chip for here to make this 486. So you basically remove this baby, you put a 486 chip in here. It's a DX upgrade chip from the likes of Cyrix, and it's basically pin compatible. It'll actually fit in the slot and it'll give you 486 speed. Now with the AST type machines, because you got this 32-bit access, in theory you should have the full usage of your 486 and you should see a significant improvement in speed due to the quality architecture that AST used. The idea behind these particular boards, which again I mentioned in the last video, but we're going to talk about this one again. The original idea behind these boards was there is a 386 version of this board. I have the 486 version of it, which I showed you before, which I think what we'll do is in the future videos we'll actually assemble that machine and see if it still runs, so that'll be interesting. So I don't have the case anymore, but maybe we put the 486 case into the 386 and make a laugh out of it, you know. But basically what we have is a board for 386. In theory, you just do a quick update on the BIOS, you take this daughter board out, you put in a 486 daughter board, and bang, you now got a 486. And then the final upgrade was to basically make the 486 into a 586 or a Pentium machine. The idea again was to be able to take out that 486 daughter board, remove it out of the system, and import a Pentium class machine. So yeah, so that's what you can do with these boards. So let's have a closer look here at the chips. Okay, so at the top of the board here, the bottom of the board I should say, it is actually the bottom of the board, we have the cache control chip for the 386. We then have the 386 chip itself, which is an Intel 386 DX 25 MHz. Now this doesn't contain a Maths coprocessor, so you have to install one. So right beside it you have the socket for the Weirtech processor, or Weirtech Maths coprocessor. And then moving along then, we actually have the coprocessor which we've installed in this machine. So this is an 387DX 16 to 33. So what it's saying there is this chip will run anywhere from 16 to 33 megahertz, depending on the speed of the main CPU. So in this case it's 25, so the Maths coprocessor will run at, have a guess what, 25 megahertz. So it gives you that range. So you want to verify that it actually is able to do that. Otherwise you'd have a Maths coprocessor that would be running at a slower speed to the Intel chip, which is what you don't want. You want to be able to run at the same speed as it, or faster. So if this chip just said 25 megahertz, let's say, and we had a 386 16 megahertz in the slot, it won't matter, it'll run at 16. But if you had a chip that just was at 16 and you were then running it on a 25 megahertz machine, it would run slower and cause bottlenecks and problems with the system overall. System stability would probably be interfered with as well. Okay, and finally over here then we have the system RAM. So there are 4 modules of system RAM here. I just noticed right now that one of them is different. That's interesting. Must have been a faulty piece back in the day. I only noticed that now, so there you go. How's that? You like that? That's good, isn't it? So let's put this back into the machine. But before we do that, we'll have a quick look at the video card that we're going to put into this machine. It is a 16-bit ISA. Again, we know it's 16-bit by the bottom of it. So it's ISA connector. So we have the 8-bit bus. And we have the extension which gives it the 16-bit bus. And as far as I remember, this video card has 1 megabyte of onboard memory, but we will be able to verify that when we run some of the demos. Again, some of the demos that we want to run were suggested on one of my previous videos, but I couldn't find them anywhere. So in the meantime, over the past few years I've been watching other people like the likes of Phil's Computer Lab, and he basically has kindly allowed people to access his batch file on his website, and on his website is a whole suite of demo, basically it's this demo batch file, all the demos are all built into it. So we basically put it on and run it on this 386 and see what happens. I'm not expecting spectacular things, but at least being at 386 25 megahertz, we stand some sort of a chance of getting some sort of speed out of this machine, but I certainly wouldn't be pinning any hopes on it. But one thing of interest is an AMD machine that I don't know where the hell it is. I know the box it's throughout, but the motherboard and CPU and that, I don't know where it is. But I remember an AMD version I had of the machine, of the 386, with a 40 megahertz chip on it, I could just about get Command and Conquer, the original version, to run on it. It would be running, wouldn't be brilliant, but it was running. So if I could ever find it, it'd be great to put it in a better video card, because I only had a 512 megabyte Western Digital video card in that one at the time. So it'd be interesting to put in a 1 megabyte card into it on the ISA slot and see if it would run, you know, reasonably well, because it was running where you could play it. Yeah, that was interesting. One of the things I always find is that they say, you know, X game will run on a 486. A lot of times never had that happen. I had a lot of trouble with the 386s running anything, so it's great to you know, finally be past all that and be able to actually run stuff on the likes of a 486 or a Pentium. But yeah, okay, so we're going to reassemble the 386, because we've taken all those parts out of it, and we'll have a quick look at what's in the machine and what hardware I've put in there as well. That'd be of interest, I suppose.